everyone see it?
Yes.
Yeah, it seems fine.
Okay, thank you. Be presenting today on the Chesapeake Bay Bridge crossover automated lane closure system, the ALCS. Just to give you some background for the William Preston Lane Jr. Memorial Bridge, referred to as the Chesapeake Bay Bridge. These are dual spans that are along US Route 5301 that connect the metro areas of Baltimore, Annapolis, and DC to Maryland's Eastern Shore. At 4 miles, these spans are among the world's longest and most scenic overwater structures. To give you an idea of the importance of this critical link in the regional transportation network, the closest northern alternative roadway route is 45 miles to the north, and the southernmost is 140 miles to the south. So this is a critical link in the regional transportation network. The original span was opened in 1952 and provides a 2-lane roadway typically for eastbound traffic. Parallel structure was opened in 1973 and typically provides for 3 lanes of westbound traffic. It should be noted that the approaches on each side are 3 lanes in each direction. So the 6 lanes that are provided on the approaches have to go across 5 lanes on the bridge, which then causes during periods of heavy traffic incidents and construction that 2-way traffic operations can be implemented on one of the spans. So this really set up the purpose and need for this project. The Maryland Transportation Authority Police requested a system that would decrease lane closure and contraflow setup time, decrease incident response time, and provide for a safer environment. In order to further this purpose and need, Maryland Transportation Authority Engineering, Office of Engineering and Construction developed a concept for the Eastern Shore crossover. This concept was conceived as a remote operated lane closure system, and this would replace personnel response for the deployment of temporary traffic control devices, signs, cones, etc. So the ALCS system is a integrated ITS system of devices that advises of closed lanes approaching the 2-way traffic crossovers that allows MDTA operations and maintenance staff to remotely close these lanes for contraflow operations on either the north or the south bridges to address peak eastbound capacity, incidents, and construction. It should be noted as we started this project, we were only working on the Eastern Shore crossover, but subsequently we also added a ALCS system for the Western Shore crossover that's going to be implemented as part of an all-electronic tolling project. Some of the ALCS ITS elements that are critical for implementing this system include enhanced lane use signals, DMS signs for ALCS warning messages, and then really one of the critical elements are the variable arm length horizontal swing gates, which help to remotely close these lanes to avoid the personnel response to move cones for lane closures, as well as illuminated pavement markers to guide drivers through the crossover movements. In addition, there were other project elements. We replaced all the lane use control gantries and static sign structures on the eastern and western shores, as well as adding additional gantries to increase notification of lane use control. Traffic barrier replacement and installation, signing, marking, maintenance of traffic, electrical modification, stormwater management, erosion and sediment control, and landscaping, as well as testing, commissioning of the system with integration into the existing Bay Bridge traffic control system. So the enhanced lane use signals and the warning DMS as part of the ALCS are full matrix color DMSs. The lane use control signals are typically 5 feet by 5 feet by 6 inches thick. The warning message DMSs vary in size. Multiple types and vendors were evaluated during the design process, and ultimately the basis of design products that were selected are from Daktronics' Vanguard product line. The next element of the ALCS is the horizontal swing gates. Multiple types and vendors were evaluated during design. We looked at both vertical and horizontal swing gates, and we looked at crashworthiness, we looked at wind loading. Ultimately, Versilis's horizontal swing gate product, which provides for a MASH-tested product and wind loading up to 95 miles an hour, proved to be the basis of design product for this project. The last ITS element is the illuminated pavement markers. There's 4 runs of the IPMs for each crossover. Multiple types and vendors were evaluated. The basis of design product was the Hilltech Limited LED line Sun DV. This provides for a fully submersible, encapsulated, and corrosion-resistant product to guide drivers through the crossovers when they're activated. The safety benefits that are expected from this project include increasing safety by reducing crashes, providing for superior incident response, and a safer work environment for employees. This should provide additional benefits to customers for savings of less setup time, which should reduce congestion and queuing that are associated today with the manual lane closure operations, provide advance notice for incidents to reduce congestion and queuing associated with late lane changing, and increasing the reliability for commuters. Operational benefits are expected to include freeing up time for maintenance personnel to perform other routine facility maintenance activities, as well as reducing their setup time for lane closures for two-way operations. As this was a new system in Maryland, there was the desire to make sure that outreach was provided as part of the project. MDTA commissioned production of video visualization. As part of the video visualization model, they also created the ability, a model for MDTA's use to actually pan and view and zoom in throughout the actual project limits as part of it. It can be used for public outreach as well as for presentations to senior management staff. Both the Eastern and Western Shore projects are currently in construction. These videos depicted the four main operations plans, and operations plan A is two-way traffic on the westbound bridge with normal traffic on the eastbound bridge. This is a typical operations plan during heavy eastbound traffic in the PM peak period. Operations plan B is a westbound north bridge closure with two-way traffic on the eastbound bridge. And then operations plan C and D are various lane closure operations on the westbound bridge. With that, I'm going to try to share a video, a sample of the video that was developed. So this is starting with operations plan A as captioned.
I see that the video is still quite long. Do you think we can maybe shrink it because we're really late with our timing?
I can, if you let it go for a little bit more, Francesca, I can cut it off. I won't let it go for the full. Let it get through this.
That would be great. Thank you very much.
Sure. So actually in this view here, you're starting to see the gates that actually appear on the left as part of this operations plan, where the left lane is closed to allow traffic to enter from the opposite direction. You can see them starting to enter the crossover. And so that's the Eastern Shore crossover there, where you see traffic crossing back over from the North Bridge. Okay, thank you very much. With that, I'll stop it. Thank you.